on audio and image files using hybrid Crypto-Stegno techniques. And our presentation just goes like this. We're going to be looking at background and motivation, literature review, methodology, results, and we concluded there with some references. So the world of information today of ICT has been actually advancing sporadically, and as a result of some of this, there has been a lot of risk in transfer of sensitive data. And with this, IBM, report from IBM in 2023 actually shows that 95% of different organizations are faced at least one cybersecurity related incident. And out of this, 51% are likely to increase security in terms of investments. And also, on the other hand, according to, there's another research that also says, research article that says 55% of businesses said they would have rather charged customers for the occurrences. And these are many more for some of these occurrences that happens in terms of information with the day and age and time that we belongs to. But when we look at all this study actually have looked at different studies by revealing that while some of the internal team of the organizations are under investigations, and they discovered that some of these data breaches, the attackers and themselves, they revealed that astounding 27% of them. So this reason is why we're presenting our topic that says the study presents a two-tier security approach that may be effectively utilized for safe transfer of data and also transformation and transmission in terms of keyless cryptographics. And this is the first thing that we'll look at in this. And on this note, the study motivation, it's about, we're looking at cryptography in terms of decryption and encryption, where we look at the plaintext to create a ciphertext, and the recipient can actually decrypt it with the secret message that is embedded in contrast. And also, transmission of data can actually be made secure by combining these two techniques, or three more in terms of hybridizations. And these data are encrypted so that only the intended recipient may decrypt them in terms of the contents when it is being jumbled and concealed behind a curtain, and it does not encourage attackers along the line. And some of the literatures have actually been able to unravel that investigation of least bits, the least significant bit was actually used, and most significant bits were used in terms of pixel values differencing, which is PVD techniques that are used in picture in terms of steganographies. With the mean square errors, there are quite different approaches that are also being used, which is the LSB, the least significant bit, and techniques that have viewed the peak significant to noise ratio, PSNR. And also, there are some studies that also look at the SSIM, which is the structural similarity index, and values based on some of these MSBs. And quite a lot of studies have actually been able to look at different embedments and also cryptography concealment within the line. And our methodology is where we propose that consists of cryptography and steganography techniques, where we look at different algorithms and we'll combine them in terms of the LSB least significant, and the Rivest Shamir was actually Adleman, and Advance Encryption, which is more or less like about hybridization of different algorithms. We now look at this by determining some of the accuracy and combining the various algorithms. And this helps us to be able to see that the outcome of what we've done is actually much more outstanding. And the process we look at is where we collect the data sets, we look at data cleansing, processing, and we look at the AES cryptography for RSA. And also we transpose that to the LSB, steganography, and encryptions of Adeniyi, and also and we look at different evaluation models of those data sets. So our methodology actually went more further with a block of chunks of size of bits of 126 and the AES encryptions. And we looked at the Ramchander algorithm as a symmetric blocks by deciphering some of them, and it uses different keys in terms of 128 bytes and also 198, 192 bytes, and also 256 bytes to convert some of these individual blocks. And this cryptography algorithm was displayed as this process that we have, where we input these files and we convert the input file into binary format. We get the total length of those secret message, and we decipher it by generating an AES key bit and encrypting them in terms of binary array. And we now cipher the text from our AES encryption ID passed down to the RSA, and we generated the RSA public keys and encryption of those plain text, so that the other end of the receiver or within an organization can actually be able to have a very good security steganography encryption method keys to be able to decipher their codes. And the metrics that we look at is the peak significant to noise ratio that are too commonly used in metric for assessing the effectiveness in terms of mean square errors of the approaches, and this serves as a foundation for us. And we went further to look at this process of the LSB, the least significant bits, and we repeat the same process: input, convert the message to binary, we convert the images, and also iterate some of these pixels, and we embed them and repeat the same process until we get an output of those images along the line. These are the results that we looked at, which is the figures that actually is very, very outstanding for us. That even in our presentation, in our articles, we presented those processes in different areas. I will model these data sets and also the images. But at the end of the day, the figure we have, which is that of the figure 2 and figure 3, examples of secret image that was concealed with the cover image. And the figure shows that the steganographic images gotten with the LSB, which is the least significant bits. And also we presented on our table as well in our results that the hidden images of LSB, the values of this PSNR for algorithm, when you compare them, are about 94.1192% when you compare it in terms of the metrics of the output. And also the image that we also have, which is the figures, it shows that the stego image of the LSB is actually outstanding when we look at the file size, which is the file size of 560 kilobytes compared to every other sizes along the line. And the mean square error was actually 0.000192. So we concluded that most frequently security is provided by using some of this steganography and cryptography, or even both of these hybridized formats involve sharing of a secret key. But in this study, a method that combines cryptography and steganography is a novel with keyless transformations, where it was actually designed by our team, and which increases security to a higher level when you compare to using only the steganography approach alone or cryptography alone, combining them with that of the RSA models. With all this, it increases security to a higher level, and the system of steganographics approach, it also helps us to be able to differentiate some of these methods using different formats, while we compare it to a state-of-the-art algorithms and methods that are used to be able to display these message lengths. And it also helps us to be able to look at the Unicode values for encryptions. And the AES key was actually encrypted using the public keys and RSA. And the RSA key was actually concealed to cover an image using the LSB and F5 algorithm separately when we compare them. And the recipient was able to receive the picture stego, after which the encryption key is decrypted using the RSA algorithm private key to produce the ES. So on this note, we concluded again as well that the hybridization of this encryption algorithm can actually be used in software application, can be used in terms of images, can be used for systems or designs that require exchange of data to be able to secure. And research conducted shows that the F5 algorithm performed better in terms of the LSB, and showing the PSNR 96.98822 with mean square error, which is 0.1353, while we compare it to the PSNR, which is 94.1, and also the mean square error, which is 0000.1920. With this is actually helping us to see that the upgrade that we've actually been able to, it's very, very unique. And thank you for this presentation, and I hope you've been able to, and these are some of our references, and I'm open for question and answering. Thanks so much for this. Can you hear me?
Julius, can you hear me?
Yes. Thank you. I'll finish my presentation now.
A very interesting presentation. My question is, by combining the two different techniques, you're increasing the computational load. Do you know how much more effort the computer needs to do to implement your algorithm?
So now, for in the terms of computer actually you can, is it in terms of which kind of format of, is it you're talking about images or you're talking about different text or emails or what kind of format? So now what we've done, yes.
For example, images are quite
bigger.
Bigger.
Yes.
Yeah.
So with what we've done,
comparative study.
yes. With our comparative study, with what we did, because we actually compare to state of the art of what we did in our research. So we actually start using this kind of approach, whereby, normally if you're sending an image, let's say you're sending a result of a student or probably a group of image that you don't want people to be able to decipher. So now when we run it through our algorithm, we're able to encrypt it and also minimize or reduce that image to maintain the same quality, so that when we send the deciphering code, encryption code to whoever is the recipient, it maintains the same resolution, and also it gives them something to be able to work with without jeopardization of an intruder within that network. I hope I'm able to answer you. We've actually been able to implement this in some of our institutions that we collaborated with, because this collaboration is about 3 to 4 institutions. If you look at the authors, were about 4 or 5 of us from different institutions, and we're able to implement this with what we do within the institution as well.